Greetings, people who are watching this live stream, even though probably no one is here. And today we are today we are going to make the top level of the project, connect the instruction cache to the core, and run some programs. Right now I'm connecting carry and zero to the LU test bench because I forgot to test those flags. Plus, sorry for not telling anyone, I made some changes to the assignments of carry and result in a more optimized way. By concatenating carry and result here, and then putting this here, I removed the intermediate add sub, and because let the compiler take the job. So now we got our ALU. Let's execute the test bench. And let's spray. No errors. Now let's see if the results are still correct. A, B, result, carry, and 0. The 0 flag works. Let's go.
Also, for the 0 flag, you can just put if equals 0. You don't have to do the NOR.
You are right. I was just, I don't know. This LEU makes me remember it's kind of a copy, it's kind of a copy of my first LEU on System Verilog out of memory. And I will just write like this. Alright. But it was, I don't know, out of nostalgia, but now so if anyone in the live stream, even though no one is here, is wondering about who was the person telling me about the 0 flag, it's Jordi Capo, the best, one of the best teachers in the world, the person who taught me System Verilog alongside other members of Learn to Do Shit. Alright, okay, we have to write the top level. And okay, I don't know how I will organize everything. I'm not gonna call this. Hmm? Let's see, I'm gonna increment the volume because my Discord is in a very low volume. Alright. So oh, I forgot. Oh, here now I'm sharing my screen. So I'm not gonna call this top level. This is going to be called CPU because we are connecting the core with the instruction cache. So module CPU input. Uh, okay, let's start with the basic one. Clock enable sync reset. I think the hardest system, my point of view, to make in the CPU was halting. I chose the right backstage to perform the halt. Let's see, 7.0 data in 15.0 inst in. Now for the outputs, memory write enable, memory request, and also um, address out and data out. Okay, now I'm gonna call it data address. And module CPU. Now let's connect the iCache with the CPU. I think that's probably the easiest part. Let's instantiate the CPU first. No, the core first. Core. Uh, clock enable and sync reset. So let's see. And clock enable. Okay, clock is clock. Clock enable is core clock enable because making a special wire called core clock enable because we also have the pipeline stalls. No, not the pipeline stall, the cache stalls. Uh, sync reset is sync reset. Instruction in. Let's make another wire here. Call it instruction bus. This one is going to be connected to the output of the iCache. Capo does. Am I the only person who calls the instruction bus, or do people call it instruction bus in general? Let's see. Going to put some Mozart music.
I was playing with cats. I've definitely heard called the instruction bus before.
Ah, alright. Because I don't know, it felt strange that I was the only one. That the only person I found calling it instruction bus was myself. Let's see. Data in, data in. Okay, data out, data out. I don't know, but it feels so nice to stream my development. I feel like streaming is helping me to improve my communication skills, even though I'm talking alone a ton of times. I know it makes me more confident. Instruction address, the wire here. Now let's instantiate the cache. One question, is it possible to, when you instantiate a module, is it possible to assign a constant to an input? Or do I
Yeah,
have,
just put it. Yeah, just put the constant inside the parentheses.
thank you for the info. I cache, because there's a pin I put called mrec, where is it? Here, and a pin called request because I took my cache from the SRM's S2 cache, and I really don't feel like removing it. I'm too lazy. Let's see. I'm gonna put the music again. Clock, clock.
Oh, at the end of that call earlier today, um, the person was like, "Yeah, if you or someone you know is looking for some investment money, let's get in touch and have a serious conversation." And I started laughing. I'm like, "Yeah, the only thing I do is hardware." Like, "Yeah, that's hard for us." I'm like, "Yeah, I know. VCs don't touch hardware."
Huh? Sorry, I'm sometimes bad at understanding when people speaking fast.
I was talking to Data, but Data wasn't listening.
Data's def. clock enable request constant one. Address in is inst address from mem is instruction in len. Instruction out is instruction bus. Address out is inst address. I have finished the top level. No, not the top level, the CPU. Now I have to make the top level for testing. Hmm. Right. Now I will make a test bench for the CPU. Let's see. Reg 15 of IROM 123
Okay.
down to. Alright. Okay, back to music. Two, three, four, 5, 6, 7, 8. Register 1, F0. Hold. So let's see. An error here. Just realized that if the clock is called till, then this control signal is disabled. So clock state is set back to 1. So to prevent that, right. Right, maybe this is the cause of the reset. Huh. That's strange.
Hi, Ethan.
Hello.
Oh,
Is
dang
this
it, he was muted.
Hmm?
is Yan Lon my Yan?
Yeah, that's Ian.
Like great, I need to bully him for I need to bully him for you know what?
For the digital blackface.
That's not what I was gonna say, but that's even better.
Oh god.
So, how's it going, fellow creatures of the dinner plate?
Oh, it's going.
I'm live streaming the development of my CPU.
I remember seeing these diagrams when I studied clock rate, but I've never seen any application for them.
Never. We are in the server about FTCAs and you've never seen something like this.
I assumed this was a solves problem, and I do want to say all of this highlights the shittiness of the professor. Like, if there's no application, I don't want to learn it. And if he managed to make a computer hardware course abstract,
Let's go, my load immediate instruction works. Okay, let's try with harder instructions. Hey, what the fuck?
Wait. You're 14, but you listen to classical music?
Yep.
You're a wild card, I ever tell you that?
Wait, let me lower my volume.
You're a wild card.
What?
You're a wild card, not gonna lie.
Wild? What does that mean?
It's like, I cannot read you and I cannot make guesses about what you do and what you're like just by reading.
Oh, thank you.
You need to manifest the energy of being that one 14-year-old who shows up out of nowhere and kicks everyone's ass.
Let's see. A U B should be 1. Okay, I'm gonna. Uh, RS1 buffer, RS2 buffer. Okay, correct. Now, intermediate RS1. Okay. Intermediate RS2. Okay. Now from the LU A B result. That's not supposed to happen.
See you guys around.
Who left? A B 1. What the heck? What the fuck? Okay, I think I need to check the test bench of the ALU. How strange. How fucking strange. When is couple coming back? Okay, back to listening to classical music. Hmm. Okay, this is strange. It's not supposed to fetch that way.
Yeah.
Hmm?
Oh, hey, Ethan, what's up?
Hello.
Hello.
Hi,
Hello.
Capo. I'm suffering with instruction cache. Maybe if no, like this. No.
How are you designing what you're building?
Me.
Yeah.
And an error I found was that when I'm fetching the cache lines, when I'm fetching the words in a line to a line, um, in the first section of the line, I fetch one instruction, but then in the next part, I fetch the same instruction. I think it's. I will show you.
No, I mean like not like how are you going about designing this? Like when you went to do this, like where are your notes? Do you have like a diagram or that you've made or written down or
um,
anything
grit,
like that?
written down, and it's in the comments. Give me a second. Um, Here we got three phases: the initial phase, the fetching phase, and the ending phase. The initial phase, busy state is set, indicating that there is a cache miss and the CPU needs to be stalled. The offset pointer is reset, just in case, because sometimes the logic is unpredictable. Same for the ending phase and state register. Then we start the fetching phase. The old tag is replaced with the new tag. The offset pointer points us at the line offset in both cache and main memory, and the offset pointer is incremented and the input word is transferred to the cache, and this phase takes about 16 clock cycles. Then in the end phase, busy state is reset and the offset pointer is reset.
Okay. So you're just gonna have like three phases. Like a lot of times when I start doing looking up like just like state machine diagrams and stuff like that and like learning how state transitions and stuff work is really helpful.
Oh nice. I should look into those diagrams because really
Because a
strong.
lot of times you can like once you kind of like write out the notes and you design it out for in like a state transition diagram, then the code kind of like writes itself in a way because you kind of know, oh, well, what makes it go from here? What happens if it's in this state? Well, if it gets this, if this event happens, it goes here, or this one, it goes there, and you can just kind of see what it's supposed to do.
Ah.
My cats are on crack.
Life of a cat owner. So you can see when I go here, the same instructions the same instruction is repeated here and here, and then the next instruction is here, and that's not supposed to happen. Suppose this one should be load immediate. Well, it's load immediate. Then this one is add immediate, which will be this one. The next one is hold. And it's not working properly.
It looks like it's just off by one.
Yeah,
Off by one.
and repeated here. Well, repeated here.
Infamous error.
Let's see the clock pins, and then the address out. Okay, address 0, you get this part. Meanwhile, this one is waiting. Oh, hmm. Maybe if Where's address pointer? Address out here. So I'm gonna multiplex it, and if busy, I'm gonna copy this. Oh wait, -1. I think. No wait. Let's try with +1. No, no, I'm not getting load immediately. Why? Oh, wait, it was here, and then I want to show Mattbatwings the power of pipelining. Mass of the Batwings, if you are watching me, let me know what's your opinion on this building. I don't know, contraption. I don't know how you call it, but of this machine
Circuit.
circuit. Thank you. No, same error. Same error. For fuck's sake. Hmm. So if it's not busy, if it's busy, no, if it's not busy, then I fetch the first part of the freaking memory.
Okay.
Then, if it's fucking busy, Why is life so cruel with me? Maybe I could make another state register called interface, and basically I will wait one clock cycle, and with that one clock cycle I get the data and then continue fetching the rest. Wait a second. My gosh. Maybe. Oh, it should have been busy state, not busy. Uh, I don't know how much time I've been live streaming. Capo, would you say that it's possible to make Mattbatwing's BatPu2 but without a further execution? Finally! Finally! Capo, I fixed it. I fixed the issue. Okay, I fixed the issue now. Couple, I have officially fixed the issue with instruction cache. Now I'm fetching. I have no issues with fetching. Now we can properly test a bad PU. Clock, uh, internal clock enable here. Um, instruction in. Yeah, it works. Now,
Jesus, I didn't realize this, but 128-bit numbers are actually kind of hard to guess.
what?
Yeah.
I just did the math. 'Cause I was starting questioning my systems. Is this a large enough number to use as like tokens for sessions to like just as a simple way to against brute forcing? It on average it would be take 10 to the 20 to the power of 25 years to brute force against it.
Yep.
I don't know why, but that's so much higher than I thought it would be.
You
Hours
can
are a bitch.
abuse you can abuse heuristics to speed up that time significantly. That's why most encryption and stuff is on
Fake.
like 256-bit basis for like usually at the minimum.
Damn, that's with like 80,000 attempts per second. So any web server that's like, you're not going to get more attempts than that, at, like cracking sessions and shit. Damn, that's wild.
No, I thought my
Can you
thing
actually
worked.
can you use heuristics to bring that down significantly? Because it's not like a
Yeah.
password where you can guess normal words and shit.
Yes, it as far as I understand, it works with any like if we're talking about like AES, it works with like no matter what you're encrypting. The heuristics are based on the algorithm used to like okay, just so we're clear, we're talking about like something where you're you're like encrypting something with a 128-bit token.
No, I mean like you're generating a token to be used as an authentication token, like a UUID sort of situation.
Oh, no, no, no. Okay, no. So I misunderstood what you were saying. When you're actually using a value like that to encrypt, you can use heuristics about the way that the encryption is done.
The like entropy and shit. Yeah.
Yeah, like a whole bunch of bullshit. However, if you're just using it like a UUID, forcing that is hard. The reason that you use an algorithm like UUID is because most of the time the randomness of however you're picking that token is so not guaranteed that even over a very like low number of attempts, a collision is very likely because you're usually using like pseudo-random number generation. So the UUID algorithm basically implements a whole bunch of bullshit that makes it as statistically unlikely that there is ever a collision as is humanly possible, basically. Um,
Hmm.
Yeah. Did a lot of research. I ended up using the Google's own like little UUID library. It's written explicitly for the purpose of authentication tokens. So they're like allegedly cryptographically secure, and the fact that they're pseudo random doesn't mean that they're easier to crack.
yeah, as long as they're using like a proper algorithm like UUID or something, then it's fine.
They're secure except to Google. Just kidding.
Correct.
Well, that's all very convenient. I'll be right back.
Okay, this is cursed.
Yeah, it's funny. Having your backend be kind of slow or using like a more higher level language like Golang or Node.js is in and of itself somewhat of a security feature because it limits how many attempts they can make per second. No, boss, it's not slow. It's more secure.
Well, I mean, until they figure out a way to denial of service you, but yeah, I mean, until then, sure.
Why?
Fundamentally, being able to handle fewer requests per second
Oh,
means
hey,
that
Ethan.
they, so long as they,
Mart,
uh,
welcome.
uh,
I'm live
uh,
streaming.
whatever it's called, like use that bandwidth, then, like you can no longer serve normal users, and then your denial of service. Also,
That don't mean they gonna get inside though.
uh, incorrect because most things are not atomic. So, for example, depending on how you're concurrency internal to your server works. Let's say that you first, like, access the user records or something, and then you make another request to the database that says, hey, okay, I updated your session token, for example. A sufficiently bastard denial of service might clog your server so hard that that next part never actually happens. Depending again on how like your concurrency works in the server.
Ah, got it.
Yeah.
Also, can we just bring the streaming channel back?
I just joined where people were.
No, I figured, but like back when we were doing the pork, had the streaming channel. Streaming
Welcome.
channel is back.
Yeah. So, why am I
So,
getting?
what did I miss? What did I miss?
Test bench errors.
Ah, okay.
I'm getting this instruction for 2 clock cycles. And it's the first instruction. Maybe I should make a state register that tells you if the CPU has. Okay, you will see. Core. I'm gonna make a register called state at first. Where should I put it? Initial state equals 0. Here.
I need to go help make dinner. I'll be back in a bit.
Alright.
See you in a
Yeah.
year or two.
A
Yeah.
year or two.
Couple left for 1 hour.
And that was the last time we'll ever hear from Cap ever again.
Dang.
Let's see. Clock state. Okay, initial state is reset just in case.
Mhm.
Every life is just in case. Else begin initial state equals 1 and sync reset initial state equals 0. Then internal clock enable, where is it? Here. Plus initial state. I hope this works. No, wait. Then initial state is gonna be let's see, the call stage, instruction in, Um, Now let's see. CPU test bench. Core. Clock. Internal clock enable. Instruction in. Now let's see. Are for fuck's sake. Why? Why? Oh, I forgot it has to go to the right backstage. I'm crazy. I'm so crazy. Why isn't it loading? Why? Why isn't it getting FF00? Why? Oh, by the way, Mart, I found out something interesting about hex files for System Verilog. You can specify the address of data. You can put @000, then the data, then put @001, the data. Tell her clock neighbor. Oh, I forgot to put my classical music.
Is that the sound of suffering or the sound of success? It looks like the sound of suffering by what you're share screening.
No, it's no success, Mart. It's no success. Finally.
You okay?
This is the program I loaded in. Load immediate register 1, 0 hex F0, then add immediate by 1, basically increment, and jump back to the add immediate instruction. And it
Okay.
works. It works.
F0, F1, F2, F3, F4, F5. Okay, well, question. Why is the Oh, that's 2 instructions. 1 instruction and then another, the jump. Increment, jump, increment, jump, increment, jump. The first one is happening in 1 clock.
Yes. Yes. Oh, and also.
Why is it 3?
And
Is that a delay slot?
yes, a delay it's a bubble. Let's check the flag, the carry flag. See if some effect was made. Where's the flags? See flags. It worked. It set the flags, Mart. It set the flags. It set to 0 and carry out. Then, because we got fetch, decode, execute, and write back. And well, this is the real state of the resistor 1 without forwarding, so it looks strange, but it's correct. We got the carry flag working. I
should probably go work on homework.
Alright.
See ya.
See ya.
I know, right?
Right.
Not my first choice either. Alright, bye.
Bye. I Slickudis Slickudis have created the first implementation of Batwing's BatPu2 with pipelining, instruction cache, and all of that on System Verilog. 3 records. 3.
Take that, Redstone Army.
Take that, Redstone Army. Take that. Instead of placing some redstone dust, why don't you verilate some bitches?
Yeah, that was my quote, but okay, come on.
Thank you for the quote, Mart. Thank you for the quote. We could test.
Okay, what was it? Let me actually try to remember the exact one. It went something like this. Why don't you stop laying down fictional red dust and start and go verilate some bitches instead? You have delivered. Holy fuck! I need to learn about caches.
Delivering this
Like
to the world.
implementation. Maybe I'm overcomplicating all of this because I need to think in terms of how many block rams am I gonna use. You just built a cache. You don't give a fuck.
By the way, and Capo told me that you should that because our caches are small, we don't need to use block RAM for the tags, just normal registers.
Yeah, it's an exception, honestly. For bigger caches, I would need to consider the tags being in block RAM as well.
Maybe for L1 we use registers, and then for L2 and L3 block RAM.
Which you know what that means? Minecraft is is a different optimization game than in real life. Because Minecraft, I mean, you ask some people what their cache configuration is, and they look you dead in the eye because they didn't even know what they built. Like how to categorize it. What kind of cache is it? They just built a cache. Turns out in Minecraft, the most optimal one is fully associative caches, but those are never ever a good option for big caches in real life. Like you settle on some like 8, maybe 16 way associative. It doesn't go more than that.
Mm-hmm.
Minecraft has the option, the perk of the third dimension, let's say.
Third dimension. By the way, I've just found out Minecraft cache is cursed as freak, and they normally use one single line that contains 100, for example, 128 bytes.
I said it's fully associative, or even worse, that it only like instructions, like instruction memory, instruction cache. That's what actually, I think I know what you were confused about pages
Yes.
of code. Imagine it like a book. Your book is your whole program, and you have only one page visible at a time. Like you turn the page over, you go to the next one. And that's what the cache does. It only holds one page of instruction memory.
Oh. Now that makes sense.
Which is weird. Because also another thing they don't usually do is they don't have not that deep of a call graph. Like they only go like 4 or 5 layers into like a function calling another function, and so that's why everyone does hardware call stacks. Nobody who is going for maximum performance is doing stack pointer and stack in memory.
For example, the BatPu2's call stack is 16 deep. I could actually change the size to something larger because that doesn't affect software at all.
We're talking about systems that were most similar to the first processors ever built on a chip. The 4004, for crying out loud, had a call stack inside of it.
3 layers of code.
Literally, in the first handful of processors Intel ever made, they ditched the call stack for stack in memory. It is a different optimization game. That's why you can't compare. That's why it's weird when someone learns computational redstone, and then tries to do it IRL, because it's a different game.
They don't have.
I do recognize that you are streaming this, and probably someone else is listening, and I'm happy that someone else might, hear my rant.
Don't care about that.
I am saying all of this as a person who was doing computational redstone, and now I'm doing exclusively real life design, FPGA and stuff.
We are intellectual smart. We know how real life works. I don't know how redstone works exactly. What I can say is they don't know the pain of the C state.
The pain of the what?
Of the Z state.
Oh, Z. Yeah. I don't know if this will be understandable to many people who only know redstone, but essentially, redstone is not 1 and 0, as I had told you before. It's 1 and Z. because the off state of redstone is recessive. It is not active. Like if you mix a 1 and a 0, the 1 prevails. The output is 1, and that's why you can do OR gates by just connecting wires. That doesn't happen IRL because both 1 and 0 are active, and if you connect them, I'm gonna use another one of my quotes here. On the short term, it's called bus contention. On the long term, it's called hot chips, the crispy chips. It's like connecting a batteries plus to a batteries minus. You're gonna get heat. You're gonna burn whatever wire you connect the batteries ends with.
I got another phrase. Bus contention is like the cheap's Mortal Kombat. The winner survives and the loser emits magic smoke.
Emits light and then magic smoke. Technically, every electronic component can be a light bulb at least one, at most once. At least once.
Yeah.
At least once.
Like the fusibles. I think the C state in Minecraft, because you said it's 1 and C, it's like a combination of 0 and C, or maybe just C, because there isn't electrical noise.
What is a combination of 0 and Z?
The Minecraft redstone 0.
No. Why? Z? No. Z means it's not driven. It's essentially like Z with a pull-down resistor.
Oh.
That's not common. That's not common because we usually have when you have these outputs, you usually don't have the transistor pulling it high. You have the transistor pulling it low. So the 1 becomes the recessive state and is controlled by the pull-up resistor, and the 0 is active. And that's called open drain, open collector, depends on your technology. That's the opposite part. That's the opposite arrangement with redstone. The 0 is the one that is recessive instead of the 1. And so essentially you have 1 and Z and not 0 and Z.
We got an invisible pull-down resistor.
Yeah.
Yeah.
It's just the different system operates in a different way.
And they are lucky they haven't suffered electrical noise. For example, when I first started using TTLs, I didn't know about electrical noise until my dad told me.
Wait. TTLs have pull-up resistors, no?
Nope.
I think it was the CMOS ones that just floated.
I don't remember which ones because I don't remember which types I had, but I would get.
Like if you find a chip like an LS series, 74 LS something, and you leave its inputs unconnected, it's usually defaulting to 1, from what I've seen. But you are advised to always drive the inputs of CMOS chips, so 74HC series.
And I also remember when I had my first FPGA, that one that got fried because of a short circuit.
How did you manage that? Like, I have an FPGA and I don't know how many times I have subjected it to torture, honestly.
It's not my fault, it's the fault of the manufacturer because it randomly started not working. I didn't do anything. But well, before that, well, it didn't have pull-down resistors, so you would get random electrical noise if you didn't connect pull-down resistors from the outside. So I always had to do that. And guess what? How lucky can I be? Before knowing System Verilog, that thing fucking broke. I was testing it.
Well, you were testing it?
I was testing it with VDF schematics.
Oh. Oh, with quart. Oh.
With Quartus
Yeah, I don't do
Media.
it.
I know.
I did it once with small proc. I'm not doing it again, okay?
Me neither, me neither. And
Also, I did something even more sinful for small proc.
oh, what?
You kids listening, don't gate your clocks, okay?
No, Bart.
I'm sorry, I gated. Like there was a PLL, right?
Yes.
The PLL is it takes in the external clock that's about 50 million hertz, 50 megahertz. It takes the clock, and in this case, I wanted to make it run slower so you could see the output. So I made the PLL that took the frequency down to as low as you could get. But that PLL needs to essentially stabilize when you start the FPGA. And it has this output, like there's the clock output for the slower one, and then there's another output for the locked. Like it's accurately giving you the frequency that you have asked. And I just took the locked output and I undid it with the clock.
Nah.
I didn't. Okay, it did work. But don't do it.
At least it worked.
I was running it at like 10 hertz.
So this thing works. I should test branching.
Yeah, you should before you call it working. Actually, I did that too. I called on my implementation's successfulness. Success. After it had demonstrated execution of just add I. At this stage, I was still unrolling loops to get Fibonacci going. You get me?
Yeah.
I just needed 2 instructions. I just wanted add I, because you want to get some values on registers. You know, like add makes registers, derives a new value from just registers. You can't. You need add I, or it's RISC V. So add I becomes load immediate essentially if you give it the 0 register. You need that instruction to introduce new data to a register, essentially. So add I and add. You can use add I as well for moves, because again you either put 0 immediate or a 0 register for the yes, you can use add I for moves and for load immediates, same instruction. It's really handy. Kids, if you implement a CPU, use 0 register. It's really nice.
It's really nice. Not like that French guy.
Who?
Do you remember the other day when we were reading some brain rot designs? There was that the French guy who didn't know English could still find. I think the post is still up. Give me a second. I'm not gonna show it on stream.
You've done 4 streams, each one 1 hour? In a day? Oh, you really have a lot of free time.
Well, guess what? Today was I don't know how you say, when you don't have school because of something related.
You had a day off.
Yes, day off. For celebrating something that I don't freaking know.
I still need to do that assignment. I talked about working. I still haven't done the MPI assignment anyway.
Oh, for fuck's sake. I missed Starship Flight Test 6. Okay, back to working. What I was looking for. Oh yeah, I'm looking for the spreadsheet of Mattbatwing's instruction set. I thought making the multiple types of writing operands was gonna be hard, but I only needed 2 control lines. But well, 2 control lines! Guess how many control lines I needed to make for this CPU? Oh, we are on dev. I'm feeling lonely. Okay, meanwhile, BatPu2 ISA. Let's look for add, sub, nor, and XOR back shift. We have to test the branching. Branching subcode B. Condition. Condition for carry, it was this one. Wait, carry. Because it's an overflow.
Okay, so I was deafened for a bit because I wanted to. I gave your stream a look. Man, my voice is so different to what I hear when I
Yeah,
speak.
that happens to me, but I hate my voice when I listen to it. I prefer. I would
Also, yeah, not just my voice. There's something even more annoying that I noticed. My accent. It's more pronounced, for lack of a better term.
more pronounced. Isn't that better?
More pronounced. I mean, that I sense the existence of a pun somewhere in there, but yeah, no.
What's a pun?
A pun is a play on words.
Oh. So I got load immediate to 0 hex 20, 32 basically. Then I decrement this with add immediate and
what's the at sign for at the start of each line?
Oh, this one indicates the address. This is how System Verilog.
Oh, so at some address, some data. Yeah.
Yep. So load immediate.
System Verilog? I thought. No, wait. This is valid for read memates?
Yes.
Why did I not know this?
Well, now you got the new information. That's useful.
Okay, thanks.
So I decrement this one without immediate basically an overflow. Then I branch with carry because there's always carry unless it's 0 and I want this to reach 0. So I jump again, decrement, jump again, decrement. And when I reach 0,
Yeah.
then there's no carry. So I continue here, I load it with FF just to verify. Okay, maybe with 50, just in case. Then I hold. Okay, new Slickudis phrase, just in case. Oh, I'm gonna see if my labs want to look for the live stream chat, but I can't find it.
Yeah, I was about to ask. Do you get any messages in there?
Previously I had a window for that, but let me check.
It says join the conversation to interact with the creator and blah blah, but I can't open it.
How strange. Let's see. Check.
It says join the conversation to interact with the creator and blah blah, but I can't open it.
Oh, there's a guy who said, "Hello man, good luck for you." Respond. Thank you. I can open the chat, by the way. I don't know why you can't. Try refreshing the page.
No, it's probably the numerous extensions I have that lobotomize YouTube.
How many times have I been streaming?
This is the 4th one. In the series, at least. I don't know if you... Oh, that's why. Yeah, found it.
Nice. I will still look for the option of reading chat from...
Oh, yeah. I can see it.
Nice.
Okay,
Okay,
I can see it now. Okay, so the extension is called Unhook. It's... Well, I use Firefox. It's on the Firefox marketplace. It allows you to remove some parts of the YouTube user interface. Most notably shorts. I can see it now. Okay,
say hi to the streamer, Tan Ramsey. Throughout the chat. Okay, let's see. CPU TV. Test bench. CPU. Core. How much time? 2 hours. Longest stream ever. Oh wait, wrong part. Martander MC, the best Greek digital designer.
yeah. I have to say, it's kinda pain doing hardware design in Europe because everyone insists on using VHDL, and I fucking hate VHDL.
No shit, Europe failed on semiconductors.
And no shit, Europe failed at computer science. They invented JavaScript. It's the only thing they invented that's successful. But at what cost? ECMA. Oh, by the way, the official name of JavaScript is ECMAScript. It's Europe.
It worked. It's set to FF. Conditional branching. Check.
Oh, ECMAScript contains JavaScript. Aha. It's a superset. Okay. Of course, it was Sun Microsystems.
ECMAScript. Let's ping Capo and tell him that the CPU works.
Who?
Capo.
Yeah. If he returns from his bajillion-year worth cooking session.
It takes so much long for him to cook because he first has to visit the dragon's lair, steal the eggs, travel to Africa, get the cocoa.
I saw the waves down the Africa.
Okay, this is
Take the time to do the things whenever they. No, I can't sing. Just don't. I'm not gonna try anymore.
Guess how much. Guess the year where Teen Titans Go was created. That Rainbow Teen Titans show.
It doesn't look new. I would say 90s, 80s. It looks animated. I mean, it is animated. But
No,
honestly, I had never seen the show. I just know of its existence.
Not the Teen Titans Go that looks like anime. I mean, the Teen Titans Go, the modern Teen Titans Go. That this one, that is 50% of Cartoon Network's show.
Yeah.
It was created in 2013.
The fuck? Oh, 2013, TV series 2013 and ongoing, okay.
So there's an episode, when I saw it as a child.
What does this have to do with
System
Verilog?
Not really System Verilog, but it's Capo.
Yeah.
Just watch the whole thing.
Where is my sandwich?
I do not know.
And I do not care.
Yeah, bro, I know you're serious about your legendary sandwiches, but come on!
It wasn't just legendary, it was perfect. For years, I've worked to improve my sandwich making skills. I traveled the world to learn from masters of sandwich construction.
Oh man. This is you getting every component of a CPU.
But I wasn't satisfied.
Holy fuck!
Every bite I took was
Salami
haunted by the
origami.
knowledge that I could do better.
Salami origami.
Until one night, it came to me, the
It even
perfect
rhymes.
sandwich. After 3 days of work in the lab,
Oh no,
I
if
had
you're
it.
gonna introduce
Perfection
chemistry
on
into
2 slices of bread, which were also perfect. All that was left was to crisp it in the refrigerator. However, when I returned, it was gone.
Someone stole
Well,
it.
that's the longest story
Now it's
about
no
making
more.
a sandwich.
So that's
Damn.
That's
about that.
yes.
Chemistry in the kitchen, you should. It prefers be called gastronomy instead.
Gastronomy. Capo. When Capo makes dinner, everything that happens in the video happens to him.
Yes. It is no wait. It is the magical time period. Everything clicks when Capo makes dinner. He's away. Holy fuck! It's 1 a.m. You know, time flies by. Having fun.
It's the fun of the stream.
Yes. You know that maybe someday someone on the internet will be like, oh, that's what That's what Mart sounds like.
That's what the famous semiconductor designer sounds like.
No, I'm not saying that. I'm sure it remains to be seen. What I'm saying is I haven't uploaded a video on my channel with my voice on it yet.
You have to make a Phoenix Plus live stream.
Yes. No, not live stream. That's sorry, but ain't nobody got time for that.
Okay,
You know what? You did the bad apple ones, right? You did
yes.
the bad apple ones. That's something I would like to do. Something that grabs someone's attention, like a 5-minute video,
I will.
and then we build from there.
I can send you the Logicim hex file.
It is not needed, honestly.
No?
I said I wanted to do it myself, but
Ah, okay.
I do wanna know. What was your source, like how, like your original video that you converted to the 16x16 thing.
And even convert it. Guess where I took it from? Give me a second. You will see.
Oh, it's a specific YouTube video that has the quality and whatever. Soji cereal.
Mr. Beast drama news. You know this video, right?
Yes.
I checked the GitHub. The hex file isn't here. You have to go to and wait. I'm gonna go on full
Where
screen.
else?
You go to branches. And here.
No. All. There.
And then
Someone. 37 commits behind main. Okay.
and
Now
this
that
one,
explains.
DMEM. And I just took it because digital supports Logicim hex files, so why not?
Bruh. Yeah. That's not gonna cut it. I want this thing displaying on a VGA monitor, okay?
Oh. To display it on a VGA monitor. Well, and also please teach me the magic of VGA and not by saying look at the digital thing.
No, it's digital has a very, like, that's how I learned too. It has the component it has is an accurate, like, emulation of VGA as a timing standard. It complains when you are 1 clock cycle off, so like you need to make it perfect. Conform to the standard.
And I
But
think
in
it
reality,
has
because, like, standard VGA, standard VGA resolution, 640 by 480.
Yes.
It's 480p. That's how 480p exists. It's the standard resolution. But the width is 640 because the standard VGA is 4:3 aspect ratio. And they specify some timings for it. And turns out it's 640 horizontal pixels. They give you some more delay at the end of the line. It ends up being about exactly 800 pixels worth of time for each line, and the whole screen is 525 lines worth of time. So if you multiply 800 by 525 by 60 FPS, theoretically,
500 by
if you do the multiplication, 525
25 times
800 by 60, you get 25.2 million pixels per second. The standard VGA pixel clock is not 25.2 megahertz, it's 25.175 megahertz. So it is not actually 60 FPS, it's 59.93 FPS because America's television system is fucking stupid. Don't search. I mean, unless you want to go in a rabbit hole.
I want.
Sure, okay. American television is not 60 FPS. I mean, the analog one. All this is dead. Analog television is not broadcast anymore. But we still have to fiddle with the standards it left behind, right?
Oh, by the way, does digital VGA only support 8 colors because the inputs?
No. No.
No?
No. It can do a lot. It can take buses. I'm pretty sure it does 32K colors, like 5 bit per bus.
Let's see.
Or more.
I/O
Peripherals.
Peripherals here.
VGA,
Let's.
I think it automatically sees it. I don't know. Again, I think I had sent you the minimal VGA circuit.
Yeah, but I think I lost it.
You want me to send it again?
Yes, please.
Okay, message.
And thank you for telling me about the resistor ladders. Now I can make digital to analog conversion.
In part, thanks to an electronics YouTuber named Marco Reps. I am aware of such method. If you have the pins to spare on the FPGA, it is the fastest way to convert a digital signal, a set of digital outputs into an analog signal.
I will wait for the file.
I'm serious. Give me a sec. VGA 1. Bare minimum. Okay, there you go. I found it. Bare minimum VGA. It's the circuit that is required to generate the timing for it to work correctly. Like to open, like when you run this thing, it's gonna open a second window for the VGA.
Yeah, I tested it. It made the second window and open.
Open recent. Yeah. Where did you put it? Oh, in downloads. Downloads. Alpha. Just write B. Oh, there you go. Bare minimum VGA. Dig. What the fuck is all this? Why did it list my repository there? Anyway, the error. Whatever.
If it works, it works.
I have you can see each area that is boxed is the same. It's just interval detector. So what it does is it just I used the flip-flops, but the flip-flop and the multiplexer and the NOT gate, they form an SR flip-flop. I used the flip-flops because this was intended for FPGA, so FPGAs only do flip-flops. So these are SR latches, okay? Set reset.
Let's see the
clock. The clock is just maximum. You want as fast as possible.
1 kilohertz.
No, well, that's 1.6 megahertz.
Oh my god.
And that's slow. That's slow. That's like how much? 25.175 divided by 1. No, wait. 6. 1.6 divided by 25.175 is times 100 is 6.3% real life speed. Which is about 4 FPS.
For
The
FPS.
VGA, like window, updates about 4 times a second. So yeah, you can just change RGB and you can just change the RGB inputs. I'm just using the pixel indices to get a pattern out.
Oh yeah, it only has 1 bit of input, I think.
Yeah, so you can change it.
How?
You can just give it a different bus size and it will accept it.
I could try.
You don't change those. Those are timings set in stone.
I just remove the splitter.
Yes.
What's the bus size of this?
That's just the 10 bits. It's the size required for 800 horizontal indices.
10 bits, alright. We grab the first. I will grab.
Here, the multiplexer is just 3 bits. Multiplexer is just 3 bits. And you do need the multiplexer here because you want the color inputs on the monitor to zero out when you do sync. Like you're not in the visible area anymore.
3.
Change this to 3. Change the max to 9 bits.
Yeah, I already changed that. I'm gonna
give it constant or something, I don't know.
Also the constant, I changed it. Oh, you're right.
You just need a different size bus. Also, it can take non-uniform sizes. So for 16-bit, you can do RGB 565. For 8-bit, you can do RGB 332. And I think it goes all the way up to RGB 888. But I'm not sure.
It works.
There was a limit. Like if you give it a bus size too big, it's just gonna not do anything with it.
We will be able to play BatPu2 with this.
It's gonna require a shit ton of memory.
Well, you're right. What's the minimum size of BGA?
This is the minimum size, the smallest resolution standard. But of course, you can double or quadruple the pixels.
Yeah. Another thing we could try making is
remember 640 by 480. 640 by 480. Those are quite divisible numbers, right? By 2. 640 you can divide by 4. By 4 again. You can divide 640 by 16, I think. You can do 40 by 30 pixels if you want. Same timing. You just drop the lower 4 bits of the pixel index on both X and Y, and it will just do 40 by 30 pixels.
Nice. Now we have to implement this on SB.
And this is the trick. This is the trick that many computers used. They had one set of timing signals. Like the output was always some standard resolution that was 640 by 480 or some other one. 800 by 600 is also common. It's called SVGA as a standard. Super VGA, whatever. 800 by 600 is another nice set of numbers. But 640 by 480 is the standard VGA resolution. You can essentially downsample it Oh god. No. You don't want this. It's never gonna start. It takes a couple frames for the window to open, you know, to get from digital to get synced.
How
At
does
50 hertz, you're gonna be waiting.
wait. How much time?
For 504,000 seconds.
And how does VGA, how does this part work here? How?
Those are specified within the pixel for each standard resolution. So if you go look at the sketch before, look at this horizontal sync pulse. They say that if you count the pixels correctly, like between 0 and 800, well, 799, the indices, horizontal sync pulse appears between pixel ID 655 and 751. And that's the time it has to be low, because it's default high, active low. Same thing for vertical. They define signals. They define the timings for those. And there was a site I used to refer to. It's called TinyVGA/VGA timing. If you can find something you like in there, but don't look at the obscure ones. They may not be supported by a lot of things.
Okay.
This is my reference timings. The site I sent you.
We know about CPUs, but we didn't see about GPUs at all. Well, not CPUs. Let's not see about that.
This is not a GPU.
No.
We're not kidding ourselves here. This is literally the 0.1% tip of the iceberg of a GPU. An old one, because this is VGA. This is the circuit that generates your video signal from video memory. This is literally the display controller, not the GPU. The GPU works on the video memory. It's between video memory and the CPU. Between video memory and your output is this circuit.
Oh, what we have to see? We have to make a PPU.
Oh god, yeah. The Super Nintendo Entertainment System is a really interesting video system, like 2D accelerated graphics, easy to understand.
Yeah.
Which I have actually implemented in digital. I wrote a bigger circuit for this. Tile map, essentially a grid of characters. It reduces the memory consumption of this by a lot, because instead of defining each pixel, each color of each pixel, which is, as you know, and do multiplication, 640 by 480, 307,200 pixels. So at 1 byte per pixel, which is 256 colors, is not that good of a color rendition, like color depth or modern systems. That's gonna take 307 kilobytes of video memory. Which need I remind you that D0 Nano doesn't have in BRAMs by a long shot. So if you wanna reduce memory consumption, you introduce layers of abstraction. So you remember the thing I said by downsampling the VGA by 16 on both axes, you get 40 by 30.
Yes.
Well, if you do it half as often, you get 80 by 60. In each block that you call 1 pixel is 8 by 8 pixels on the screen, right? What if you had one memory location for each of those 80 by 60? You call that a character, and then for each of those locations, you can define which set of 8 by 8 pixels stored on a secondary memory is displayed. That's called tile mapping. So you go from 307 kilobytes for primary memory to 80 by 60, say 16 bits to describe each entry. You drop to 38, no, kilobytes, no, is that a bit too much? 80 by 60 times 2, 9.6 kilobytes. It dropped from 307 kilobytes to barely 10.
Barely 10.
But of course, now you can only have a set amount of 8 by 8 pixel patterns, right?
Yes.
But if you just want to display text, you just draw a font, put it on a block RAM, and then just refer to it with another block. It's really nice. If you just want to display text, it is a very good solution.
Kinda.
And you can those characters can be outside. No, not outside. Those characters that you drew a font on, if you put them in RAM, you can allow the user to change them for whatever pattern they want, and then you can make like early 80s style games. And that's what the NES did, and the SNES even better, and many other computers of the 80s.
We can make one section of the tile map ROM.
Yeah.
So where we put the basic things that can't be modified, that the operating system will always use, the characters, and then the rest for the user. No, it's not tile map.
If you have an OS involved, usually the user gets 0 direct access to video memory. That's what the OS is there to do. It's there to separate hardware from user code.
Maybe what the OS could do is... No, bad idea.
Like nowadays, these kind of techniques don't get talked about because they're all abstracted away by the video driver and the OS. And you only get to see the frame buffer. Behind the scenes, the VGA is driven by sophisticated piece of hardware, your GPU, which has a lot of acceleration functions, but those vary. For each GPU, it's different what they can do. So whoever made the VGA, not the GPU, whoever made the GPU provides a driver so that they all look the same to the OS, and in extension to the user. So they conform to a specific set of APIs. That's why you see some GPUs say, oh, they have this and this support for OpenGL, or this and this support for Vulkan or DirectX. Those are the hardware in conjunction with the driver, what sort of rendering APIs they support.
I've got an idea.
That's how it works nowadays. A high level software interface that didn't exist back then. You had to program. You had to add support for every single video card you wanted to support.
Let's make a video.
Handle it manually.
Hmm?
And handle it manually yourself. Same story for sound. This is how it was during the DOS days, okay? It wasn't pretty.
My dad told me that. And he was a fan of sounds. He wanted to be a DJ, and then they ended up as an electronic engineer because he liked analog things and sounds. And most of the things he proposes me to try doing is systems related to sounds.
Yeah, that's actually a good introduction to a lot of things.
Yeah.
Because you can go from analog to digital quite easily, and digital signal processing is a very big field actually. And this, as far as I know, and as far as other people have told you and me, and yes, DSPs are the predominant market for FPGAs.
Yeah, but it's also for me the funniest.
It is fun. I'm not denying that making your own CPU is fun, but I'm saying that the market for FPGAs is mostly on DSP.
Yeah, that's true. That's true.
Or embedded if you're doing something very esoteric, or doing research work, of course. But those are niches compared to DSP. And DSP is a very vast field. Like you can find FPGAs doing stuff on many high-end devices. Like if you have like an electronics lab, you have a desk multimeter. It's pretty, and some of them, not all of them, some of them that higher range ones, they have multiple FPGAs in them.
Something that
Yeah. Yeah. It is. Now you're talking about topology because you have the CPU. You have to interface to the video memory somehow. One way is to have it go through the VGA circuit, and the other way is to have the memory shared. But if the memory is shared, that means you either have to share the bus, or you have to have two buses on the memory, which block RAMs have two buses, but don't rely on block RAMs. There are not that many on the D0 Nano. I tried.
Maybe my idea is making mini CPU while it can't calculate, but you send a command. Maybe okay,
Yeah.
not a CPU. It's more like terminal controller.
VGA. It's the video graphics adapter. That's what it means.
Oh.
It's whatever you put behind it to populate memory that does the smarts.
But
Get
where here pen.
Pineapple, apple pen. Fucking no. Return to 2024. I mean, honestly, at this point, pen, pineapple, apple, pen is a classic. And what the fuck did they just say? How the fuck is pen, pineapple, apple, pen a classic? At this point, do you even know what that is?
Wait, I need to listen to it. I sometimes don't even recognize sounds.
No.
Too late.
Oh shit.
PPAP.
You remember it or whatever.
I have pineapple.
No.
Pineapple pen. Apple pen. Pineapple pen.
Those traumas, Mart. Those traumas.
No, okay. I prefer this every day compared to the TikTok slop of nowadays.
Okay, you are right. TikTok is shit. They are for unprofessional people who waste their time destroying their sense of attention, having an attention span of a goldfish. Meanwhile, us are intellectuals who destroy our attention span, but on CPUs.
Yes. And sometimes I forget I am in the same generation as, you know, some other Gen Z.
Me too.
Famously mocked. I mean, actually, no, that's Gen Alpha. Mocked by the lack of attention span of Gen Z and Gen Alpha.
Guess what? Next year, Gen Beta starts.
Actually, what is gonna be the name of that next generation?
Gen Beta.
Oh, they're gonna get all the fucking hate because they're like, the Gen Alpha's gonna be like, "No, I'm the Alpha and you're Beta," and then fucking the Gen Zs are gonna be like, "I don't care."
Wait until Gen Sigma arrives.
Gen
Gen
I think
Sigma.
we will have broken that pattern by then.
Yeah.
Oh no, it's a thing.
What? What is a thing?
Generation Alpha from 2010 to 2024. So it follows that Generation Beta will be born from 2025 to 2039.
No, wait, it can't be. Gen Alpha isn't. It isn't 2012. Okay, it's the first years
Yeah,
of
it's
2010.
2012. You know what?
Hmm?
Whatever it is, Generation Beta, whatever the fuck it's gonna be called, is, well, at least partly gonna be the last generation to have been born before the rollover of the signed 32-bit Unix epoch. That's a very nerdy thing to say, honestly. I recognize that, yes. You know what the signed 32-bit Unix epoch is?
Yes.
It rolls over on 2038. So have fun, Gen Beta people, or future me, future colleagues of me, fixing systems that still use those.
Wait, Gen Z ending year. I don't want to be Gen Alpha.
It's 2012.
Oh, I'm saved. Bart, I'm saved from being mocked. Well, still you are Gen Z, but you watched Skibidi Toilet.
That doesn't say anything. Stop saying that. I gave it an honest try, and I stopped, and I'm not talking about it. You are the ones talking about it. You are the ones obsessed, not me.
No, Ethan is obsessed. That's why I always remember, because he always says Skibidi Toilet. He's got the brain fried.
Yes.
And he's trying to infect me with his fried rotten brain.
Yeah. I can hardly believe this guy is actively serving in the Israeli military right now.
Probably it's a way to cope. Skibidi Toilet is the only content that he can watch because he loses internet connection in the shelter.
No, you don't understand. Israel mandates all their citizens, even women, some amount of years of service for men, and a fewer amount, less years for women.
How much years that he has to do?
I think it's 5, but don't quote me on that. I mean, they are. Some might say the war. Some others might not like the term war, but they are in a conflict right now.
Yeah.
So they're not in a hurry to reduce that quantity of years, let's say.
And now
Well,
He's
here
part.
in Greece,
Hmm?
here in Greece, they only go for men, and they only take them for like a year.
And when do you have military service?
I have successfully postponed it until the end of 2031,
Oh, nice.
but I'm not gonna do that until 2031. You know, you get your degree.
Uh-huh.
When you get your degree, you know that's where your life outside starts. Let's say your main sequence, astronomy term, main sequence of human. You should probably get the military service out of the way before starting a life, you know?
Yes. Well, guess what? I don't have military service.
You know what you have instead?
What?
The most clingy password in existence in humanity's history.
What clingy password?
You have the most clingy passport in humanity.
Oh,
You can never ever revoke Argentinian citizenship.
I'm stuck forever. But well, no military service at least. The military service was removed after the 1994 constitution was written because it had a bad fame because of the last dictatorship.
Your neighbor Adolfo wasn't very happy about that.
Yeah, he wasn't. By the way, what was the meaning of martial law?
Martial law, I'm pretty sure it means military is the one that sets the rules.
Oh,
It's military time. Not that's a term that exists. Damn you Americans! Why are you heathens using 12-hour time? Stop it.
let's check the redstone army, and I'm gonna spam. I have finally freaking finished my CPU.
Yeah, so it was just, you know, a chat to fill in the time. Not really related to the CPU.
I love chat for filling time.
What the fuck? You have been streaming for 3 hours?
Yes.
3.5 hours. Okay, this was like, okay, fuck it. I'm done. I'm gonna finish it today. No matter what. No matter what.
What are you going to finish?
No, you were like that. Your previous streams were like, okay, 1 hour, 15 minutes, 1.5 hour. Okay, here, have a 3.5 hour stream. Why not? Enjoy my beautiful voice, YouTube servers.
Wanna ping illegal melon? Okay, that's for you, because why not?
What about Melon?
I'm gonna ping him in the massage.
Yeah. So about Phoenix Plus again. It's going, but not as fast as I would like. You know.
Oh.
I'm in a pretty demotivated period of my I don't want to say life because it's like a cycle. It's not gonna leave and never return. It's like a cycle. Like I'm gonna use another term from astronomy because yay astronomy. Is it astronomy or climate science? A bit of both. Milankovitch cycles. It's different effects on various like the change on various aspects of the system that determines the Earth's climate. And it's essentially a bunch of oscillations that they add up, and you get some more complex signal that determines how hot or how cold this year is.
Oh.
Ali.
Now that the CPU works, I'm gonna copy the files. So I think I got an idea to motivate you.
No, even if you don't do anything, I will motivate myself eventually.
Fuck your sleep. That's all.
No.
If you are busy on the day, fuck your sleep.
I literally can't do that.
Why not?
Because the whole point of I was waiting for summer to pass so that I could come back to university and fix my sleep. Like, I'm not exaggerating. Summer was the most, at least my previous summer, was the most uneventful, boring 3 months of my life. I not only hate the hot weather of summer, I dislike how empty each day is. If you have nothing to look forward to in the next day, obviously you're gonna fuck your sleep. And I did. I ended up sleeping at like 6 a.m. and waking up at like 2, 3 p.m. and then eating dinner, eating lunch. You hardly even call it lunch anymore, at like 6 p.m. and then dinner at 11. Like, this was not a healthy arrangement, and it was all summer's fault. Because the moment I got back to university in October, everything fixed itself. Everything.
I'm gonna be so sleep deprived this summer.
It had nothing to do with this. I mean, I had the streak. I was doing it. I had a 4-month commit streak. You remember?
Yes. And you
Yes.
No more streak.
I did. You know what? I made the conscious decision to stop doing it because it was not helping me anymore. It was causing me a lot of anxiety. And I have, like, October was a very happy month for me, actually. And I don't know why it hit me now in November. Maybe it's my I got my driver's license recently, and I have been in quite a few close calls. Probably that demotivated me a lot. You know, I almost had an accident 3 times, like 2 days ago. Same driving session, almost 3 accidents.
Oh god, well, you are news, so it's obvious.
Yes. Like, tomorrow morning is like, I got my license past Tuesday. I haven't even done a week with license. You know?
Yes.
But even then, I almost fucked up, and that kind of really demotivated me. I haven't been working on my own projects for a long while because of other obligations. So, yeah, eventually I will get back to it. I did a commit today, which at least indicates that I have not forgotten how my code base works, which is step 1, I guess.
Step 1.
You know the ones that, like, okay, you write a project, you leave it alone for like a month or 2 months or some amount of time, and you come back to it and you don't understand shit.
That happened once to me. Oh my god. Mart, guess how many logic elements my thing uses. Okay, don't look at my screen.
Yeah, I'm looking at my desk. Couple hundred.
How many?
I said couple hundred.
Yeah, but be more specific.
500.
Close.
More?
More.
600.
Close.
700?
Yes. 700 logic
767?
elements.
767. Oh. Yeah, you are. Oh, here's the thing. Here's the kicker. Total memory bits 512. Oh, I did actually use a Bram. Nice.
Let's go. The RAM was for the cache.
Oh, you got a Bram cache?
Yes.
Nice. Does that mean that fetching takes two steps?
Well, Vav. Okay, first when there's no cache miss.
Okay. So you rip on a cache hit. Does it immediately give you the thing? Like, is it program counter gives it to the cache? Next cycle it is available for decode.
Yes.
Yes. Okay. So you replaced program memory for a prototype. Like, this is where program memory would go on a prototype, with Bram for cache.
Mm-hmm.
And then if there's a miss, you stop the clock of the CPU, right?
Yes.
And then you do a state machine fuckery to bring in more data from external memory.
Yes.
Yo, ping from Redstone Army. CPU discussion. Oh, it's man. It is him. The man.
The man.
The man himself. Pay no attention to the man behind the curtain. That's me.
Martander MC in real life. Embedded multiplier, so this is 0. Not using multiplication.
Yeah, fun fact. Those are called DSP blocks. Get the connection?
Oh!
Multiply is everywhere. Multiply and some other operations. Multiply and add, usually. Multiply a bunch of things and add them together. Or multiply something with something else and keep a sum. That's the multiply accumulate. Those are operations essential to digital signal processing.
And what's PLL?
Because that's phase locked loop. That's, as I said, I mentioned it before. That's your clock converter.
Oh.
Because the D0 nano, specifically because you have the Cyclone 4E, the FPGA, the EP4CE22FCF17C6. Yes, that's the FPGA on the D0 nano. The D0 nano has a 50 MHz clock on it. Like, the FPGA has access to a 50 MHz reference oscillator. You don't use that directly, you go through a PLL and you tell the PLL what frequency to output, and you have quite a bit of range.
And you can... How do clock multipliers work? Not clock dividers, multipliers.
I still haven't figured that out. But a PLL is essentially it's a variable frequency oscillator. It's something that you can adjust the frequency of, and then you tell it to match two like you have a signal that's one frequency, and you tell it, and you give it a second signal that is of some other frequency, and the PLL tries to generate some output, change its output in a way to make those two frequencies the same, right?
Mm-hmm.
That's called feedback. So you take the output and you bring it back to the input. If you disconnect the output to the input, that causes the PLL to output whatever frequency you give it on the second input. If you put a divider, like a D flip-flop, on the feedback, then the PLL, you give it, say, 1 megahertz input. It needs 1 megahertz on the other input to be satisfied, right?
Mm-hmm.
That means, because you have a divide by 2 in there, the input of the divide by 2, and by consequence the output of the PLL, is now 2 megahertz. You didn't double the frequency, you just told it, generate me a frequency that's double this one.
Oh.
You can't just take a clock and double it. You have to generate another one that's twice the speed in comparison to someone else. Which may sound the same, but kinda isn't. Because you're generating a new one, you're not deriving the previous one.
Yes.
You're just using the other one as a reference.
Oh.
That's what the 15 megahertz, that's what the crystal is there for. It's there for a reference, and then what you do is, the PLLs on the FPGA, they have actually two dividers. It's the divider for the feedback and the divider for the output. And so essentially you can say, give it 1 megahertz input, and then say divide by 3 for the feedback, right? Divide by 3. And that causes the PLL itself inside the oscillator to output 3 megahertz. And then you set the other divider to 2, and that causes essentially 3 divided by 2 scale on the 1 megahertz, and you get a 1.5 out.
Oh.
And that's changing those two coefficients, like the divide coefficient and the multiply. So if you put the divider in the feedback, it actually multiplies the output of the PLL by that amount, because they have to be same frequency on the input. And then you divide on the output, you get essentially a fractional multiplication on the input frequency. You can get quite a lot of range from that.
Oh. Let's wanna see the F max of this. Let's see. By the way, you're on mute. Oh, okay, not anymore. Slow and 1200 millivolts, 85C model, 124 megahertz.
Yeah, that's your worst case. But Capo really needs to tell us both about timing constraints, because I mean, you're pretty sure you have no idea what these are. I have some idea what they are, but I can't write them. To essentially say, give the Quartus in this case, give the EDA some constraints as to how data is expected timing-wise on the outputs, essentially, and the inputs. You can tell it. It's complaining here with red everywhere because you haven't given it constraints.
Oh.
Usually it doesn't. It tries to figure it out itself, and it works well enough to get a VGA signal out of the FPGA. Like, I have made the VGA output that I showed you in digital. I have made it in the FPGA without constraints, and it has displayed on the screen. But you really should start looking into them if you want to do this professionally, like Capo is.
What's a Slack?
A Slack is oh, and that's why it's failing. Slack is essentially a quantity that you have left over. If it's negative, you are failing constraints. There's no constraints, so that there's no constraints, so that it's not good. Setup means how long it takes to go from invalid to valid output.
Oh.
Like essentially from rising edge to valid output, how much time?
Ah, okay.
And hold is essentially from acquisition of this. There's a setup and hold. Setup and hold. Hold is the other side of the argument. So it's how long it stays after it has stopped being asserted. So that like the output stops being active, or how long it stays being seen as active. Well, that's like a delay. Setup is a delay, I think, and hold is something. It's timing shit. Okay, Fmax. I think you can guess frequency maximum.
Yes. I can't see the Fmax of the map.
There's a couple. What? There's a couple models. There's apparently 3 here. There's the two slow models for various temperatures, and the fast one for the 0. The most pessimistic one, it doesn't say Fmax here for some reason. The most pessimistic one is the slow 80C one.
Oh.
Because it is assuming your FPGA is literally at 80 degrees Celsius. Which makes everything slower and more power consuming and everything. This is the worst case scenario, essentially. 80C.
124 megahertz.
Scenario, 120 megahertz. Take that, Redstone Army. Can barely even get.
Take that, fictional dust fanboys.
Like, seriously, they had to, Stack Double Flow had to spend precious quantities of his time to invent an entirely new server, Minecraft server, to accelerate Redstone so that this entire field could continue developing stuff. I'm talking about MCHPRS.
Yes.
Which is actually quite a big feat of engineering, but like, why? It's a game. Okay, sure, okay, whatever. People are making their living out of this game. I shouldn't complain. No, not Sammy again.
No, not Sammy. Mattbatwing.
He has been teasing Iris for a long while.
No, wait, that's what happened.
No, yeah, Minecraft. The other video. Okay, you know what? It still happens sometimes. It still happens sometimes. Some person will see the MPU8 video Go down to the description, see the server linked URCL, not linked anymore, because Mod made his own server. But back then, when he was making the MPU8, he linked URCL instead, the Discord, the URCL Discord, and we still get people on that Discord server that come in, and all they ask for is the MPU download link. I'm not joking.
No download link.
And
You have to work for yourself.
And we have to explain them and like blah 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 blah. It is intentionally broken to prevent plagiarism and yada yada, and then they're like different reactions on each person or whatever. Same story for the Chungus 2 plus the original Minecraft in Minecraft. All that the download is intentionally broken for the same reasons.
Oh, so that's why it didn't work when I tried to run it.
Yeah.
Minecraft computers. And this is my latest Redstone computer called Iris. So far, I have shown Iris running Doom, a ray tracer, and full color Rickroll.
By the way, all of this is done in MCHPRS.
Without using
Yep.
command blocks, pistons, or mods.
Because it would be
Iris has a
ungodly
color screen
slow
that
at
works
vanilla
using
speed.
retextured redstone dust.
He had
meaning
to run this at 10 kilohertz with that server.
It can display 16 different colors using different signal strengths, all in vanilla Minecraft. Today I present my biggest program yet. For the first time ever, full color Minecraft in Minecraft.
Idea, why not implementing his CPU but on an FPGA?
As I said, Minecraft and in real life development optimize for different scenarios. What Mod made here is, I mean, obviously optimal in some way for Minecraft, but I doubt it would be as optimal for in real life design compared to other systems.
Yeah. He probably invented his own format
Also,
for...
You know what really excited me with his demonstration is he is using actually binary to count the stack size on the inventory.
Yeah, I also noticed that.
How many views has this gotten?
102k.
It needs more.
Yeah, that's true. No fucking way. I've got... Guess how much views my most viewed video has? 400k.
Judging by your reaction, happiness more than this.
400k.
Oh, I knew it. I was about there. What was that video actually?
Let me show you. You probably forgot.
Oh, that. The Pacific Massacre, of course.
303 comments. Who dares to dislike my video? I'm gonna go to their house and force them to gate clocks.
Yes. Anyway, you done with the CPU, right?
Yes, finally. I think I should stop live streaming.
Yeah, maybe it's about time for me to go to bed as well.
Before the live stop, before you leave, and minutes later after stopping the live stream, then we can leave. And so let's say goodbye to the live stream. Uh,
I hope you all become smart fellas and not fart smellers.
Thank you for watching, people who watched this, even though probably no one was here. Well,